Here we have the series 5n divided by 3n squared plus 5, and we want to use the limit comparison test to show that this series diverges. And so once again, to use the limit comparison test, we call the given series right here, we call it the series A sub n. In this case, we want to show that the series A sub n diverges, so we have to do two things. We have to come up with a series B sub n, and then show two things. The first thing is the limit of A sub n divided by B sub n is equal to a positive finite number. And then the second thing is we have to show that B sub n diverges. The series B sub n diverges. Then we can say that the series A sub n diverges. And so that's what we have to show. And so first, let A sub n be the given sequence here. And then we can let the B sub n be something similar. And normally we can just drop the constant right here. So that's B sub n. And then now we need to show that the limit of A sub n dividing by B sub n, that this is equal to a real finite positive number. So A sub n is this, and then B sub n is this. And then now we can just simplify. And so dividing by 5n, dividing by this quotient right here, is the same thing as multiplying by the reciprocal. So 3n squared dividing by 5n. And then the 5n will cancel out. And so we have the limit. Just the 3n squared dividing by 3n squared plus 5. And then to find this limit, we can notice that if we let n approach infinity, then the top will go to infinity, the bottom will also go to infinity, which means we can use L'Hopital's rule. But here, this one is simple enough. We can just divide the top and the bottom by 3n squared. So the top we get 1. 3n squared divided by 3n squared is 1. And then 5 dividing by 3n squared. And now as n approaches infinity, we get 1 here, we get 1 here. And then 5 dividing by 3n squared will go to 0, so we get 1. And so we have just shown that the limit of A sub n divided by B sub n is equal to a positive real finite number that's greater than 0. So this is part 1. And our objective here is to show that this series diverges. And therefore we need to also show that series B sub n diverges. So the series B sub n. The series B sub n is without a 5, so we need to show that this series right here diverges. And so notice that this is the same as this, n divided by n squared, and we just get n on the top. And then we can separate this. This is the same as 5/3 times 1 over n. And then 5/3 is a multiplication constant, so we can move it and place it in front of the summation notation. And then notice right here, this is a harmonic series, or P series with n equal to 1 is a harmonic series. And we know that the harmonic series diverges. But this is also the same as a P series. Here, this is the same as n to the first right here. With P equal to 1. And it diverges. Recall that if we have a P series and the P is less than 1 or equal to 1, then the series diverges. And so we have shown two things. We have shown that the limit of a sub n divided by b sub n is equal to 1, which is a positive finite number greater than 0. So that's part 1. And then our objective is to show that the given series right here, we want to show that this series diverges. And therefore we have to show that the b sub n diverges. And we have just shown that the series b sub n diverges. And therefore we can say that by the limit comparison test, the given series diverges.